Hey guys, Miss Stan's here. So, another video. I know I don't have videos very often anymore, but we have to do lesson 2 right now since the other cohort is taking the test. And we will discover how to graph linear equations using the slope-intercept method. And you have a do now on page 7. I would suggest that you hit pause right now, go do it on your own, and then check your answers with me. So when we complete a table of values, which actually you may not have done last year in 7th grade, you get to choose any x values you want and then plug it into the equation to find the y value. So for number 1, like I could pick the number 100 and plug it in for x and find out that y is 100. But I also see that I have to graph it on this grid over here that only goes up to 10. So I like to pick numbers that I know I should be able to fit on my graph. I kind of like to center it around the origin. Remember, the origin is the point 0, 0. So I usually pick things like -2, -1, 0, 1, and 2. And if I substitute this -2 in for x, it tells me that y is also -2. So this very first one really is very easy to do. The second table, I'm still going to pick -2, -1, 0, 1, and 2. And now when I put a -2 in place of x, it says -2 minus 3. So that's a -5. -1 minus 3 is a -4. 0 minus 3. 1 minus 3. And 2 minus 3. And then number 3, I'm still going to pick -2, -1, 0, 1, and 2. And -2 plus 3 is 1. -1 plus 3 is 2, 0 plus 3, 1 plus 3, and 2 plus 3. So let's just graph these. I'm going to use 3 different color pens so that we can see the difference between them. Again, hopefully you remember how to plot points. -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Something very important about drawing lines is that a line goes on forever. So I can't draw this tiny little line. I don't even want you to just put arrows right here and say you're done. It's actually mandatory for you to extend your line to the edges of the graph. Now, before I extend my line to the edge of the graph, I actually look at the pattern of these points. I can draw a straight line better if I have points to put it through. So if I continue the pattern of the points from those 5 points that I had to plot, I can then extend, and it helps me draw a straighter line and arrows at the ends. It is mandatory to label your line. Labeling the line means writing the name of the equation along the line. So this was y equals x. And I'm going to change to red and plot the next one, -2, -5, -1, -4, and so on. So I've got these 5 points. If I continue my pattern, arrows at the ends, label the line, and one more color, -2, 1, -1, 2. If I continue this pattern, so this is called graphing using a table of values. There's going to be a day that I actually show you on your calculator where you can find a table of values. So right now, this mathematics was so simple that I would hope that you'd be able to do this without your calculator. If we do 4, 5, and 6, we get slightly different lines, right? And numbers 1, 2, and 3, the lines were actually parallel. And 4, 5, and 6, you'll see that they're going to be different. 4, 5, and 6, they pick numbers for us. So this is -4, -2, 0, 2, and 4. A half times -4 is -2. A half times -2 is -1. A half times 0, half times 2, and a half times 4. And finally, 2 times -4, 2 times -2 is 2 times 0, 2 times 2, and 2 times 4. And I'll use different colors for this also. The first one is exactly what we had the first time. The line y equals x, no matter what numbers you choose, is always a line that goes through the origin. And if you remember yesterday's lesson, this has a slope of 1. Each of these points is going up 1 over 1. This equation, y equals x, is actually a very famous, I guess we could say, equation. We call it the parent graph. Anytime you see y equals x, it's the parent graph of all linear equations. It's like where all linear equations originate from, right? They originate from their parents. Number 5, I'm just going to change my color. -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2. Look at the pattern of the points. Like, use the knowledge that we had from yesterday. It goes up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Right, so I'm going to go up 1 over 2, and it continues the pattern in a straight line. All linear equations must create a straight line. The word linear has the word line in it. Linear equations make straight lines. And number 6, -4, -8, -2, -4, 0, 0, 2, 4, and 4, 8. So none of these lines were parallel. Again, remember I said the parent graph is what we compare all linear equations to. The parent graph was that blue line. I'd say my orange line was less steep than the blue line, right? It's flatter. And the green line is steeper than the blue line. So that's something important to recognize, because what we should be noticing today is that what we see in the equation actually has an effect on the line. All the coefficients of x in numbers 1, 2, and 3 are 1. And all of the slopes of my green, blue, and red line are 1. They all went up 1 over 1. There isn't anything added on at the end to number 1, so I can think about it as a +0 on the end. Number 2 has a -3, and number 3 has a +3. Take a look at the graphs. Y equals x plus 0 happens to cross the y-axis at 0. Y equals x minus 3 happens to cross the y-axis at -3. And y equals x plus 3 happens to cross the y-axis at 3. So just by the look of the equation, I actually know that the slope is going to be 1, and that the place where it crosses the y-axis happens to be that number at the end. And if what I'm saying is true, it would mean that it has to happen in numbers 4, 5, and 6. So let's take a look at numbers 4, 5, and 6. The coefficient here is 1. On the blue line, the slope is up 1 over 1. On number 5, the coefficient is 1/2. And on my orange line, it is up 1 over 2. And then on number 6, the coefficient is a 2, which could be written as 2 over 1. And my green line does go up 2 over 1. So the coefficient of x actually tells you the slope of the line. The number added on at the end, none of these have anything added on at the end, so I could put a plus 0. And guess what? They all cross the y-axis at 0. So now we can answer these questions at the bottom. What effect does the constant in the equation have on the solutions in the table? So the constant is a number added on at the end. The constant is where it crosses the y-axis. And then the next question, what effect does the coefficient in the equation, so they mean the coefficient of x, have on the solutions in the table or on the graph? I keep on really referring to the graph. That's really the important part of today's lesson. The coefficient is the slope of the line. And then we're going to use this knowledge to help us graph lines without doing a table of values. If I know what the y-intercept is, it means I know where it's going to cross the y-axis. And if I know what the slope is, I know how to make a staircase to find other points on the line. So let's take a look. That's what all of this says. It tells us an x-intercept is where it crosses the x-axis, a y-intercept is where it crosses the y-axis, and we really are only going to focus on the y-intercept for now. Remember, yesterday we learned that slope is rise over run, or we could write it as y2 minus y1 over x2 minus x1. And then this is an example. And these are examples. But you know what? I love learning by doing. So instead of just looking at these notes together, let's go do some problems together. Before I do these problems together, let's just look ahead. So this is your classwork. There are 12 questions, and then your homework comes from the textbook. So I'll do a couple of questions with you, and then I do want you to do more on your own and check with me, and I will give you the answers here in this video. So what questions did I want to do with you? I want to do 1, 2, 6, 8, and 12. 1, 2, 6. There's 12 and 8. So let's do those. And then you're going to do the other ones without me, but I will provide you with the answer. So when we look at this equation, I want you to think about that we like our equations written in a special form. What we say is equations should be written in the form of y equals mx plus b. We learned yesterday that the letter m can be used to represent slope. We didn't learn this yesterday, but I'll tell you now, they like to use the letter b to represent something called the y-intercept. The y-intercept is the place where the line crosses the y-axis. Instead of calling it a place, maybe I should call it the point. It's the point where the line crosses the y-axis. And remember that slope is rise over run. Remember also that positive slopes slant this way and negative slopes slant this way. And you'll see why I'm reminding you of that. So on number 1, if I write y equals mx plus b right above this equation. I can see the y's line up, the equal signs line up, and m lines up with 1/4, which really means that the slope of this line is 1/4. You can see the x's line up, and this says plus b, but that says minus 1. It's telling me that b is a -1. B stands for y-intercept, so the y-intercept is a -1. Remember, the y-intercept is the point where the line crosses the y-axis. So by knowing the y-intercept, I know one point on the line. I know that this point right there is on the line. So we like to always start graphing by plotting the y-intercept. It's a point on the y-axis. But now, since the slope is 1/4, I like to make my staircase that goes up 1 to the right 4. Remember, positive line slants upward, so really from that starting point, I want to go up and right. So from my starting point, I want to go up 1 and right 4. 1, 2, 3, 4. Right here is my next point. And then do it again. Up 1, over 1, 2, 3, 4. I know I'm going off a little bit, but that's all right. I can go in a complete opposite direction. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. And then if I followed that pattern of rise over run being 1/4, I really do get points that are in a straight line. So I can connect them, I can put an arrow, and I can label my line y equals 1/4 x minus 1. Done. That's how we graph using slope and y-intercept. The line has to be in the form of y equals mx plus b. If the line is in the form of y equals mx plus b, m is the slope and b is the y-intercept. And you want to list that information as you work. So taking a look here, m must be, I can't just call it negative, it must be -1. B must be +2. We like our slope to look like a fraction, so all numbers, you could always put a 1 underneath it to look like a fraction. We always start on the y-intercept because it's the only point we know. Slope is not a point. Slope is a pattern that we follow to find more points. When it's negative, it has to go downward, like what I wrote over here. So I want to move down 1 and right 4, right? It goes down to the right, these negative slopes. So we'll start at 2, and we'll go down 1, right 1, down 1, right 1, and continue. I can continue in the other direction. All lines have to be straight. Sorry, that line does not look straight. Using this pen that I'm using at home, it's hard for me to draw lines. This is the equation y equals -x plus 2. Let's go do another problem that I wanted to do. I think I'm going to skip number 6 for now. And I want to look at number 8. Now remember, we said that we like the lines in the form of y equals mx plus b. So I like y by itself. I like to solve for y. This is a literal equation. That's why I taught you how to do these literal equations. We have to learn how to get y by itself so that we could get it in the form of y equals mx plus b. So off to the side here, I'm going to write x plus 2y equals 0. I want to solve for y. Remember, you have to do your adding and subtracting first, so we'll subtract x from both sides. So I have 2y equals, and since I know I want it in this form of y equals mx plus b, I kind of like the x term first. I'm actually going to write the negative x first, and then I'm going to put a plus 0. Now y is not all the way by itself yet. I have to divide by 2. Remember, whatever you do to one side you do to the whole other side, a big giant division sign. Whenever you're dividing both sides, you have to make sure you divide the whole side. So what we learned in Unit 1 in our polynomial unit is that this denominator divides into both pieces of the numerator. I can write it as negative x over 2 plus 0 over 2. Now this can be simplified even further. I'm just going to change my color for a moment. So in front of the x is really a 1 here. So I would prefer to write this as y equals negative 1/2 x. Instead of negative x over 2, or instead of negative 1x over 2, I like it as negative 1/2 x. And then 0 divided by 2, remember 0 divided by anything is 0. If it's 0, it means that my y-intercept is 0. Actually means that I can write it as negative 1/2 x. I don't have to put the plus 0. So just remember, if you don't see a plus 0 at the end, there really is a 0 there. This is in the form of y equals mx plus b. The y's are lined up. The equals are lined up. This negative 1/2 lines up with the m. The x's are lined up. And this plus b lines up with nothing. What can I write for nothing? I can write 0. So the slope is negative 1/2. And the y-intercept is 0. So we'll start at 0. Negative has to go down and right. Right, that says right. So down 1, right 2. And you can go in the complete opposite direction. So y equals, where is it? Negative 1/2 x. That was my equation that I solved for. To be honest with you, if you wrote the original equation, x plus 2y equals 0, that's also called labeling. You can label it either one, it doesn't matter. Number 12 is another equation that has to be solved for y. So 5x minus 2y equals 10. Let's subtract 5x from both sides. Negative 2y equals negative 5x plus 10. Let's divide both sides by negative 2. Y equals 5 over 2. I'm going to show all my work, I guess. This negative 2 goes with both of these. So I guess I should write it as a negative 5x over negative 2 plus 10 over negative 2. I'm going to simplify that. Negative over negative is positive. So this is a positive 5 over 2x. And positive 10 divided by negative 2 is negative 5. So the slope is 5 over 2. And the y-intercept is negative 5. You always start at the y-intercept, and then you use your rise and run. Since it's positive, I'm going to go up and right. So I'll start at negative 5. I will go up 5 to the right 2. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. And then extend. Your lines have to go to the edges of the graph, like past it with arrows. I'm going to label it the original equation this time. And now I will go back and do that question that I skipped. Did I only skip one? I did. So this one is a little unusual because it doesn't seem to fit the equation y equals mx plus b, right? It's like missing this x, which means it's missing an m. It's like it only has a b. I can write this maybe as y equals 0x plus 4. Do you agree that y equals 4 is the same thing as y equals 0x plus 4? Which means that the slope is 0 and the y-intercept is 4. And yesterday we talked about zero slopes. Zero slopes are always horizontal lines. So if the y-intercept is 4 and it's a horizontal line, this is what I draw. This is the equation y equals 4. Now, to be honest with you, I usually don't write it with this 0x plus 4. I look at this y equals 4 and say, okay, of course, y is 4. So I go to 4 on the y-axis, and then I draw a line through it, and I'm done. So I just remember that if it's y equals some number, and there's no x in the equation, I remember this is always a horizontal line. And I remember that horizontal lines always have zero slope. So I had said that you should finish your classwork, but I'm going to leave that up to you. As long as you took the notes that we did together, and as long as you do your homework in your textbook, I'm going to say you're good. So to turn in work for today, I need to see the notes that we just did, and I need to see the homework complete. I am going to provide you with the rest of the classwork answers in a moment. So I'm going to hit pause, I'm going to finish it, and then all of a sudden they're all going to flash on for you so that you can see what the answers are in case you're curious. Okay, so I'm just going to show you the answers that we didn't do together. You can hit pause if you need to. I'm just going to slowly scroll through. You can see that I answered everything. Again, hit pause if you need to. If the line was horizontal, there was really no work to do. If y wasn't by itself and there was an x and a y in an equation, I did have to solve that literal equation for y. And that's that. So your homework is in your textbook. And I can answer questions when I see both cohorts doing the same thing on Friday. So Friday, I will answer any questions about this, because I think Friday's lesson really is some more of the same stuff. Okay? So have a good day. Talk to you soon. Bye.